Hey everybody, this is Alex Merced, and you're listening to another episode of Gnarly Data Waves. Okay, and here on episode 9, we'll be talking about building your open data lakehouse on Iceberg with Fivetran and Dremio. So a real exciting topic. But before we get there, your weekly reminder that the Dremio Data Lakehouse platform is easy, fast, and open. Okay, meaning you're going to be getting data warehouse-like functionality with the data lake type flexibility. And the only way to kind of make sure you know that is not by just believing me, but by actually getting your hands on by heading over to dremio.com and clicking on that test drive button. And within a few minutes, you will have your hands on Dremio so you can experience all the excitement firsthand at no cost, at no obligation. But that way you can see that, hey, this is what it is. But of course, we're going to have also many great episodes of Gnarly Data Waves coming up. So again, this week we're talking about building your lakehouse with Fivetran and Dremio. So talking about ingestion using Fivetran and querying using Dremio, and just basically how to kind of create that data lakehouse workflow. But next week we'll be talking about optimizing data in Apache Iceberg with strategies like compaction, sorting, z-ordering techniques to make sure that your Apache Iceberg tables are chef kisses working fast. Okay, and then after that, we're going to have Apache Iceberg office hours. So you bring your Apache Iceberg questions. We'll have our Apache Iceberg answers. And then after that, we're going to be talking about modernizing Hive to the data lakehouse. So how to take all those Hive tables that you may have sitting around and basically bring them over to the Apache Iceberg world and sort of just that whole thought process. Okay, and what would that journey look like? So if all those interest you, I'll see you there. You can always register over there at dremio.com/events. But with no further delay, let's head on to our feature presentation, where we're going to be talking about building your open data lakehouse on Iceberg with Fivetran and Dremio. And joining us today, we're going to have Coral Trevetti, Senior Product Manager over there at Fivetran, and Brett Roberts, Principal Alliances Solutions Architect here at Dremio. With no further ado, the stage is yours.
Well, thank you, Alex, for a great introduction, and welcome everyone to another Gnarly Data Waves episode. My name is Brett Roberts, and I am a Principal Partner Solutions Architect here at Dremio, and I am super excited to have our partner Fivetran join us today. We have Coral Trevetti, who is the Destination Product Manager at Fivetran, with us. Coral, thank you so much for joining. Welcome. Why don't you just tell the audience a little bit about what you do at Fivetran?
Yeah, hey everyone, excited to be here. Thanks, Brett. I'm Coral. I'm the product manager for Cloud Data Warehouse Destinations over at Fivetran, and so our focus is making access to data as easy and as simple as electricity. And so that's what we're going to talk about today with respect to our data lake houses.
Well, I'm a fan of electricity, probably more than most. So I'd love to hear that. Yeah, I'm super excited about the topic. We're going to talk about how you can build your open data lake house with Fivetran and Dremio. So a topic that's near and dear to my heart. So let's go ahead and jump into this. And I think, to kind of set the table for what we're going to be talking about today, I think we need to level set on what a data lakehouse actually is. I know that term has become more and more in focus over the last year and a half or so, but it's still a relatively new term. So let's just quickly kind of define what does that mean. And to do that, I want to take a step back, kind of go back in history a little bit, not all the way to the beginning of electricity, but just take a step back and talk a little bit about some of the technologies that have been used over the past decades or so by organizations to solve their data challenges and to kind of provide data to the business. The first one being the data warehouse has been and is being used by organizations all over of all sizes. And really it's being used because organizations are able to get that transactional consistency, the ACID transactions. They're able to get reliability and data quality from the data warehouse technology. And that's something that's extremely important in providing accurate data to the decision makers. But the data warehouse does have some drawbacks. It's expensive. Moving data into a data warehouse can create some proprietary formats that kind of locks your data into one format where you're stuck using that set of tools. And as we all know, not every use case needs the exact same tools. So there are some drawbacks there. And that's where kind of the data lake emerged as this flexible, scalable, cost-effective alternative to the data warehouse that organizations can land all of their data in. But the data lake also has some drawbacks in itself or in its holistic form. And organizations found that getting data into the hands of the end user directly from the data lake was very challenging. So what organizations have been doing for the past 5-10 years or so has been, this two-tier approach, which is really using both the data lake and the data warehouse together in order to solve their data needs. And so when you look at this here, organizations say are landing data into the data lake, but in order to get the data into the hands of the end users, they are moving data into one or many data warehouses. And even then, in order to get the data into the hands of the end users, a lot of organizations create reports or extracts or aggregates of the data, which, as we've seen over the years, the exponential growth of data has caused this to be extremely complex. It's not scalable, it's expensive. And as you're moving data into one or many data warehouses, you kind of lock yourself into that proprietary format where you can't use new tools that have emerged over the past years or so with that data. So this is the challenge that organizations are facing, and really the catalyst for why the lakehouse emerged, which is being able to provide the best features of both the data warehouse and the data lake in a unified architecture, right? Not a two-tiered architecture where you're using both of these technologies together but independently, but in a unified architecture where you're combining the transactional consistency and the ability to do ACID transactions, data quality and tracking and time travel, and the reliability of the data warehouse. You're able to use those features or have those features, but directly on the data lake, where you can still take advantage of the very cost-effective, highly scalable, and flexible nature of data lake storage. So that is really what the lakehouse is. It's combining the best of both worlds into one unified architecture. So when we think about building that lakehouse and then building that unified architecture, there are some key components that are necessary in order for organizations to get the best of both the data warehouse and the data lake. And it starts with getting data into the lakehouse, and that's where data pipelines come in. And that's where Fivetran does an amazing job of providing highly reliable and automated data pipelines for organizations to move data from a variety of their sources, whether that's third-party apps or other databases or on-prem data sources, into the lakehouse. And then the next component that you need is you need data lake storage. And that's something like AWS S3 that's really emerged as the de facto landing spot for a lot of the data lake storage. And this is because it's highly scalable. It stores a ton of different types of data, and you can really bring your open file and table formats to S3, and it's always available. I think the biggest component, and Coral, I'm sure you'll agree with me on this, is the table format, though, and being able to articulate your data that's in the data lake in a format that allows organizations to provide that transactional capability, ACID transactions, time travel. And we'll talk a little bit more about the specifics of that in an upcoming slide, but that's where Apache Iceberg comes in. So having a transactional table format and having your data represented in that transactional table format is super important in order to glean all the benefits of the data lakehouse itself. And lastly, you still need to get the data into the hands of the data consumer. And that's where you need some sort of query engine like Dremio that can directly connect to the data sitting in the data lakehouse, can query the data in place, and can provide warehouse fast performance on the data lake directly to the data consumer without having to move data or copy data. And we've also seen a lot of organizations that are empowering their data users to do more with data, really look for that self-service capability. And so when you think of query engines and being able to interact with data directly on the data lake, you need to be able to provide your data users with that self-service semantic layer. So the data consumers, the BI users, the data analysts and scientists can interact with the data just like the data engineers on the data lake. So there are other nuances of the lakehouse that you need, but these are really the core components that you need to build out the capability for organizations to achieve the benefits of both the data warehouse and the data lake. So I'm going to hand it over to Coral now to talk a little bit about what Fivetran is doing to enable organizations to move data from those sources into the data lakehouse in Iceberg format. Coral, over to you.
Awesome. Thanks, Brett. Yeah, so a lot of this is covered, right? Customers are relying on data lakes for a number of reasons. There's a lot of data that you're storing. You're housing unstructured data. fundamentally, if you're utilizing a data lake, there's a lot that you're responsible for. So you're required, to build your own pipeline for each of these sources. You're transferring that data in the raw format into the lake. Once it's there, you have to clean it, dedupe it. Compaction is necessary because incremental updates can result in a lot of smaller files. And that frequent compaction is also something that makes it easier and faster to read the data from the lake. There are a couple different components here, but fundamentally what we want to talk about is kind of when you start to move away from the current state of data lake management and you start to leverage Apache Iceberg, what are some of the benefits that come through there? So if we can kind of see some of the key features of Apache Iceberg, right? And so by applying this particular table format, there are a lot of benefits that you see, mainly transaction consistency, schema evolution, time travel, and partition evolution. Why are these things important? So for example, transaction consistency. Within Iceberg, this works by creating a new version of the table for each transaction. So each new version of the table is then used to store the new data, but the old versions of the table are still kept for reference. So you can keep track of changes to data over time while still allowing data to be accessed from old versions of the table. A second component, schema evolution. This is fantastic because rather than rewriting batches of files, schema updates function as changes to the metadata. So I'll talk about this in a moment, but in particular, this doesn't, as I mentioned, doesn't require any rewrites or migration to a new table. With regards to time travel, I mentioned the old versions of data, old versions of the table are kept for reference. So the time travel feature specific to Iceberg makes it possible to run reproducible queries on the same table snapshot. And you can use these snapshots to inspect previous changes. So there's rollback capability. You can easily walk back errors. And then you can also kind of leverage this update process of Iceberg, where each change to an Iceberg table creates that snapshot, and audits can be done on data in that way as well. Also super important with Iceberg is partition evolution. So metadata for each partition is actually kept separately, and the queries don't reference each partition value directly. That makes it really easy kind of to have new data written using a new layout. And that means that when querying, each partition layout is planning files separately using the filter it derives from that particular partition layout. And this particular feature within partition evolution is called split planning. So you don't need to go back and repartition historical data, just moving forward with data in a new layout. With that, I'd like to introduce Fivetran's S3 destination. So this is our first data lake destination, and our beta is actually going to go live later on March 16th. The benefits in particular of using Fivetran, AWS Glue, and S3 are primarily around compliance, security, ease of use, and reliability. And fundamentally, what I want to focus on here is something like GDPR compliance, right? Traditional data lakes are schemaless. And so the analogy I like to use is when you walk into a closet and you don't have any hangers, it's difficult to find all the clothes if they're on the floor. But by leveraging Glue and Apache Iceberg, we're organizing our closet using hangers. And so everything becomes easier to find. It's easier to see which data is no longer valid because you can kind of find and sort through it much quicker. And then fundamentally with AWS Glue, security is a really big feature that I wanted to highlight. So there's granular access control through AWS Glue at both the column level and the row level. And so using Fivetran, AWS S3, and Apache Iceberg, you'll see that this changes the way you might be managing your data lake or your lakehouse. And so on the next slide, we'll see kind of how that architecture changes, right? And so with Fivetran and Dremio, the lakehouse management becomes much more automated. The data lake yields itself to ELT pipeline, and customers can load the data that's raw without aggregations or transformations that are applied to them. So Fivetran has over 150 different native connectors. It supports over 150 different data sources that can be moved into a data lake. So we do best, which is, as part of that ingestion process, which is the compaction, deduplication, normalization. We anonymize PII, and we convert the data into Parquet files. So that data is written into Parquet files through the Fivetran pipeline, and then we land the data using the Iceberg table format into AWS Glue. The metadata is then immediately inserted into Glue, and your data is ready for querying. And so leveraging Dremio on top of this will allow the data to natively be consumed and funneled into your downstream users using BI tools. All right, and so now let's take a look at a demo of how Fivetran is going to land some of the data into S3. A demo of adding a connector. So you'll see I have access to the Dremio S3 bucket. And what I'm going to do is add a separate set of data through another Google Sheets connector. So I'm selecting the Dremio S3 bucket as my destination. These are all the sources, right? And so you can kind of scroll through and see what's available. But if you know exactly what you're looking for, I'm looking for Sheets. Makes it really easy to find, and we're going to hit continue setup. So I've already formatted my Google Sheets dataset, so this should be ready to go. This is a charging survey for electric charging locations in the US. So I'm going to put in my schema name, my destination table, and I'm going to grant Fivetran access to my spreadsheets. So just going to hit authorize. Okay, great. And so this authentication is complete. And now the easy part, I just add my Sheets URL. And you'll find that Fivetran will automatically populate any named ranges within your Sheets URL. So this is January data. I'm just going to hit save and test. And we'll run through our connection tests. Great, so all these connection tests are passed, and that means that I'm going to land on the, I can choose to block or hash all the columns. I'm going to sync all the data today, and we can go ahead and start our initial sync. So once I click this button, Brett will start to see this data populated into his S3 bucket.
Coral, thanks for the demo of how Fivetran very easily creates that pipeline from that Google Sheet into AWS and writes the data into Iceberg. Let's go ahead and jump into Dremio then to show how you can easily connect to your Glue catalog and start querying those Iceberg tables. So I'm going to go ahead and share my screen. And you can see here that we are looking at Dremio's home screen. For those of you who are unfamiliar with Dremio, just a quick orientation. Down here on the bottom left, we have our sources. These are all the different data sources that you can connect to, the different cloud data lake sources, metastore sources, and external databases as well. Up here on the top left, you have Spaces. Spaces is one of the foundational building blocks of the semantic layer. It allows organizations and users to save and collaborate on views of the data without having to move or copy the data. And it does it in a very easy to navigate directory type format. And in the middle here, you have your home space. This is really where you can just build your own views of the data, interact with the data, but without having to share it with anybody else in the organization. Maybe it's not ready for prime time yet. So for today, we're going to add a new source, and we're going to connect to that Glue catalog, and we're just going to query the table that Coral just sent into AWS Glue. So we're going to click on Glue catalog as the data source. We're going to name this charging demo, and we're going to just do one advanced option where we change fetching query data sets to 1 every minute. And we're going to go ahead and save this. And Dremio is making a connection to that Glue catalog that Coral just wrote the data to. So that connection is made. You can see that we have a bunch of different folders here, including the folder charging survey that you saw in the Fivetran portion of this demo. So we're going to click on that, and you can see that we have the Iceberg table already populated in Dremio. That is the charging survey. So we'll click on this, and we will run this query just to select star of this charging data set. And you see that this table has over 54,000 rows and a bunch of data here. So as a Dremio user, I was very easily able to connect to the Glue account, find that Iceberg table, and now I can do all the things in Dremio that we had talked about, whether that is, any of the ACID transactions, any of the appends, upserts or deletes, all of that. And then as a data user, once I'm ready to connect this data set to my BI tool of choice, I can very easily click on the Tableau button here. For the purpose of this demo, we connect to a ton of other BI tools as well. And we can click on this TDS file, and Tableau automatically opens up a new copy of Tableau Desktop, and it's going to connect us directly to that data set that's still sitting in the S3 and the table being in Glue. So right now, Tableau is authenticating with Dremio, and we're going to use our Dremio login credentials. And we can close this window now, and we'll go back to Tableau via Dremio. So you can see here we have all the same columns that we saw in Dremio and that we also saw in the Google Sheet. And we can start to, as a data consumer, start to run our query. So I do want to kind of take a step back and show, Coral, maybe we could do a full end-to-end use case of how a user could use Fivetran to move data from a source into S3 and then add additional pipelines, maybe join that in Dremio as well. How does that sound?
Sounds great.
All right. So I'm going to go ahead and get out of this data set here now that we just kind of showed how that works. And I'm going to go into Fivetran to that same Fivetran account that we were just in. And we have a couple S3 destinations already set up. For today, we're going to use the Dremio S3 destination. And we are going to be looking at US regional sales data. And this data set has a couple different sheets on it. It has sales orders, customers, store location, products, regions, and sales teams. And so we've already created a couple pipelines with Fivetran to AWS, one for the sales locations and one for the sales orders. And we did that doing the exact same thing that Coral just did with the charging survey connection. And if we go back into Dremio, we can actually see in the Fivetran Dremio, we have those two tables right there. What we're going to do, now that we know that these two are there, we're going to start by just exploring that data. We're going to go into sales orders. We're going to run that. And we're going to see all of the sales orders that are in this data set here. But what we can do is, because if we saw, actually go back to here, when we go back to this data set, we see that sales orders can be supplemented with the location of the stores that are making the sales. So what we can do in Dremio is actually just join those two tables together in a virtual data set where we're not actually physically copying the data. We're just creating a SQL statement on top of the data and saving that as a view or a virtual data set. So what we're going to do is we're going to go into the connection to Fivetran. We are going to go to the folder and we're going to add sales locations to sales orders. And we're just going to do a SQL join based on store ID. So we're going to drag store ID into the center here for both of those tables, and we're going to apply that. And now what we've done, and Dremio has written the SQL for us, we have created a unified table of two of the different sheets within that data set that talk about sales orders and then add more context to the store that made that order itself. So then we can save this as a view. And we're going to save this in our semantic layer under in our spaces under sales. And we're just going to call this order and store table. And now that we save this, we can do just what we did earlier and connect this to Tableau. So we're going to click the Tableau button, download another pointer file. We're going to open that pointer file, which brings us back to Tableau. And we're going to authenticate just like we did earlier using SSO to our alliances account. And now we have the connection to that join table where it's two different tables joined as a view in Tableau. So first, what we can do is we can just look at a count of the data. And you can see that we have about just shy of 8,000 records here. We can look at a count of data by product ID. And you can see that we just the product ID only shows like a 1, 2, 3, 4, 5, 6. So in this table, product ID hasn't been mapped yet as far as the name to the number. So if we go back to Fivetran, let's create a new connector and send that product data set to AWS for Dremio to connect to. So we're going to add a connector. We're going to connect it to Dremio S3. We're going to search for Google Sheets, just like how Coral did it earlier. We're going to name this sales and product name. We're going to authorize it. And then we're going to add the URL and select the name range for products. And we're going to save and test this. We're going to sync all the data just like Coral did and start that initial sync. So now we're adding a new Iceberg table to that sales bucket. And we're going to be able to go back into Dremio and supplement that table that we already made and then easily refresh it in Tableau. All right, so now that we have synced the pipeline and the data is written to Glue, let's go ahead and look into Glue and see what we have there. And we're in our Glue account. We can go to our data catalog and to our databases. And we can see that we have that sales database that we created. And now we have product name, this table, alongside the sales locations and sales order tables that we had created earlier. If we click on product name and we look at the advanced properties, you can see table type Iceberg here. And so that is how it's written to Glue. Let's go back into Dremio and add that table to our sales order and sales table. So first we're going to go back to our home screen. We're going to go to our Fivetran demo bucket. We're going to hit sales, and you can see here that product name has now shown up. So now that we know that it's there, we're going to go back to that view of the data, that order and store table, so the join table. We're going to run this, and then we're going to create another join and join that product table as well. So we'll head down and look for that Fivetran demo connection and sales, and then product name. And then for this, we're going to do it based on product ID. We're going to apply this. And now we have added a third table. And if we look at the graph here, you can see that all of it's coming from AWS Glue, but we have 3 different tables that are now joined into one. If we go back to the data tab, we're going to just save this view. And if we go back to Tableau now that we've saved the view, we can actually go, and all we have to do is refresh the table. And we now have product name alongside product ID. So instead of product ID now, we can remove this and we can add product name, and we will see the same graph, but instead of 1, 2, 3, 4, 5, we see the names for the products. And now we have enriched the data. We've provided the data consumers with more information for them to build their analysis and provide more information for the businesses to make more data-driven decisions. And we can do some fun things here, like if we wanted to look at product name by, or the count of data by, I always like maps. I'm a map guy. So if we look at it by state, we can put it into a map, and we can see the map in a heat map here. We can look at detail. We can add product name, and in the detail as the top product name, like that. And we can look at see what's the count of all the products. And if we do that by label, actually, we can look at the count by name. So I'm going to go back to the slides now, but that was just a short demo on how easy it is to really get your data lakehouse going by very easily creating enterprise-ready pipelines from your source into the lake, and then very easily connect to those new Iceberg tables with Dremio, and in seconds start providing that data back to the end users. So before we move on to the question and answer portion of this webinar, we do want to leave you with how you can get started. And it's very easy to try this and really build out a data lakehouse for yourself with Dremio and Fivetran for free. You can try Fivetran for free. You can sign up for it and then start creating connections from your countless sources. Again, there's 150 plus data sources that are out there, from those sources to AWS. And then you can also try Dremio for free, connect to AWS Glue, and start to query the tables and build out your data lakehouse. So with that being said, Coral, I first and foremost want to thank you for joining us today and thank everyone for attending. We do want to open it up for question and answers. So if you do have a question, feel free to type it in the Q&A section or come off mute and you can ask it then. Thank you.
We're going to start doing the Q&A now, everybody. So if you have any questions, put it in the Q&A and we will route those questions over to Brett, Coral, and Brenner. So and actually, Brenner, I don't know if you want to take a moment to introduce yourself.
Sure. So I'm Brenner Heinz. I'm a lead technical PMM for destinations at Fivetran, and I'm in the Denver area.
Awesome. Again, if anyone has any questions on the presentation, please do put them in the Q&A in the box. I'll also take a look at the chat to see if anyone's asking any questions in. Otherwise, I'm going to assume that presentation was amazing. And basically, I mean, I definitely now have a much better understanding of how to use Fivetran and Dremio to build a data lakehouse from ingestion to query, which is, well, here we go. Can Fivetran handle transformation after the data lands in S3, say from raw to cleansed?
Yeah, so we actually have a whole transformations kind of feature. So we work with dbt, and so transformations is something that we offer as kind of like a completely standalone feature and functionality. So yes, we can do that, and we can do that within S3 as well as any of the other destinations that we land data in.
Yeah, and we also work with dbt as well. So it's kind of awesome because wherever you are within the pipe, you can leverage dbt for those transformations, whether it's when it's landed in S3 with Dremio or with Fivetran.
Okay, here we got another question. Is Fivetran adding support for DremioArtic catalog? So basically landing it in the DremioArtic catalog. Yep, go for it.
Landing it directly. So at the moment, we aren't offering support. Right now, what we've built out is support for the open source format, so Iceberg. And on our roadmap for this year, we're going to be supporting Delta format as well. And so we're keeping kind of partners in mind while we do those, but right now our focus is those two open source formats.
Does Fivetran support the Iceberg REST catalog?
We do, but we're leveraging, I think what we're doing is we're leveraging AWS Glue specifically, so we're not relying on the Iceberg REST catalog.
That's all the questions so far. If anyone else has any questions, bring them in. Of course, make sure to add all of our panelists today on LinkedIn and feel free to reach out to them respectively with any further questions you have on their products. And here we have another question. How does Fivetran handle incremental transfer of data from new data, from new data from the source?
Yeah, so we you can basically set your sync frequency, and so as we discover new data at the source, we'll sync that in conjunction with your incremental data. And so initially, the way that it works, you'll plug in kind of your destination, identify the source. We'll do what's called a historical sync. We'll bring all the data over, and then based on the increment that's set, we'll sync new data into the destination. And so that includes kind of smaller chunks of data as well as new tables, but basically it happens at set increments.
Okay, next question. How does Fivetran avoid the small files problem in Iceberg tables?
It's related to kind of how we write the data. So specifically kind of what we decide to do on our end in terms of reading data at the destination, what happens within our S3 pipeline, and then how we land it. So that's fundamentally kind of the inner workings of Fivetran and how we land data into S3.
Mark that question as answered. Keep an eye on any other questions. But on that note, sort of like, where can people go to learn more? Not just like going to the Fivetran website, but is there like a Fivetran Twitter, Fivetran LinkedIn page? Where else can people learn more?
Yeah, Brenner, you want to jump in on this one?
Yeah, I think we have lots of channels. YouTube, LinkedIn, Twitter. Those are the main ones, but of course, our documentation is fantastic as well. I think it's pretty simple and straightforward. Those are probably the first places I would go.
Awesome. Cool. And Brett, same question. RE Dremio?
Yeah, so if you want to learn more about Dremio, go to dremio.com. You can test drive Dremio by going to dremio.com/getting started. I actually want to kind of do a little plug for Modern Data Stack Conference coming up in a couple of weeks. Dremio is going to be there. We're super excited. We have a booth. We have a happy hour. So would love for you all, if you're going to be attending in the Bay Area, stop by and check out what we're doing. We have some really cool content that will be produced about what we talked about today.
Yeah, and to add on to that, if you want to message Coral or myself on LinkedIn, we can get you a discount code for registration as well.
Awesome. That's very nice. Next question. My question is, how do you identify new data in sources, including delete at the source? Versioning required at the source? Reading logs? I guess they're trying to say, like, how do you know what's new, what's not new?
Yeah, we like compare, right? So basically, to really simplify it, we're looking at the data at the source. We know what we've transferred over to the destination, and we're, regardless of kind of the connector or the destination, we're doing that sort of comparison. And so it really depends on the connector, the source connector that you're using to land data in S3. The mechanism will vary slightly, but fundamentally, we're either keeping track of the primary keys and making sure that we identify both new data and remove data, or we're doing something on our own to kind of figure out how data has changed as it moves through the pipeline. So we're monitoring and keeping track of what's happening at the source and at the destination. It's temporary tables, and that data is deleted after 30 days. So we're not continuously monitoring, but for our purposes to make sure we're syncing the right data and landing the right data, we're keeping track.
Awesome. Last call for questions. Last call. And again, I just want to say thank you to all of you for presenting today. That was a fabulous presentation. And again, thank you always for coming on to Gnarly Data Waves. This has been a delightful time. So again, thank you, Brett, Coral, and Brenner for coming on today. And also to all those in the audience, again, we do this every Tuesday here at Gnarly Data Waves, same bat time, same bat place. Also, if you happen to be in Austin, Texas for Data Council next week, I will be doing a workshop on dataascode, so make sure to be there. And yeah, this will also be posted on Spotify, YouTube within the next 24 hours for those who want to rewatch this presentation. And we do have another question. How do you handle bot data?
I'm not sure I understand the question.
Agreed. The way they basically spelled bot in quotation marks, like it's like you purchase the data. I'm assuming. I don't think I fully understand the question yourself. Bill, if you want to like maybe put some elaboration on the question, we'll see if we can go further. Give you a moment to do so. Like Dow Jones. So I guess we're talking about like if you purchase the data from the Dow Jones, and so
yeah, we have integrations with some of our partners. I think so. Typically, those partners will leverage Fivetran to say that like you can purchase this data and land it directly into a destination. If you have, for example, Dow Jones data and you're putting it into BigQuery or something like that, you just leverage our BigQuery connector. But it's not necessarily a situation where we will have a Dow Jones connector specifically for data from there. I imagine that even the Dow Jones is like landing data within a destination, and then that's where you would be pulling that data from. So there's like an integration that might exist there, but just an example.
Got it. Okay. I think they posted a follow-up question saying like where would they look for such data? Like where would they be able to learn about data that could be bought and integrations and stuff like that?
Oh, that would be the folks that were selling the data themselves. So in this example, it would be the Dow Jones. So Fivetran isn't necessarily selling the data. What we're doing is just facilitating the data movement. And so if you are a partner who's looking to sell data to customers, we have solutions for that. If you're a customer who's looking to move data within an ecosystem, then that's also kind of where you would leverage Fivetran. But in terms of purchasing external sets of data, that would be a different
Okay, next question. How do you handle tens of petabytes of data from Hadoop sources?
Specifically from Hadoop sources.
Yeah.
There, like as I mentioned, we have our incremental and our historical syncs. And so initially to sync that amount of data, it would take some time. Petabytes is obviously a very large volume, but fundamentally it would work in the same way where we would sync the data historically. Once we have all the historical data into the source, and we would sync incrementally as well. I don't believe we have Hadoop as a source, Brenner. You might be able to correct me
I don't
here.
think so. Not at this time.
Yeah.
Okay. Cool.
But I think one of the things that you guys can do is those sources that would traditionally feed into HDFS or into Hadoop, those sources can now be moved to your S3 destination instead of Hadoop. So that could be, wherever the origin of source is, could be pointed to S3 instead of Hadoop. And then obviously there's probably a data migration that needs to be done for historical data as well.
Yeah, definitely. And if that is the use case, please definitely reach out to me or to Brenner. We're starting to think about as well, kind of like how to facilitate these exact types of migrations in a way that's like painless. So kind of what we went through is if you have S3 and you don't have a ton of complex pipelines, it's really easy to kind of start to leverage Fivetran and AWS. Obviously, if you have like a very mature system, there's going to be a little bit more thought and planning required. And so that's something that we'd be happy to help with.
Awesome. Thank you very much. I think that is all the questions we have for today. So I just want to say again, thank you, Brent, Coral, and Brenner for coming on the show today and helping enlighten the audience, educate the audience, entertain the audience about Fivetran and Dremio. And again, just want to say thank you.
Thank you for having us.
Pleasure.